Assalamu alaikum, guys. So today we are going to talk about the introduction to autonomic pharmacology. Okay. So before we going to talk about the autonomic pharmacology, we have to know about the autonomic nervous system. In nervous system, there are two parts: a central nervous system, and obviously there is peripheral nervous system. Okay. So central nervous system consists of brain and the spinal cord, and peripheral nervous system consists of the somatic nervous system that deals with the voluntary activities, and there is autonomic nervous system that deals with the involuntary activities. So the autonomic nervous system is also divided into the sympathetic nervous system, parasympathetic nervous system, and enteric nervous system. Okay. So before I'm going to talk about the anatomy of autonomic nervous system, I should tell about the neurotransmitters. Okay, so there's two type of fibers: cholinergic fibers, and adrenergic nerve fibers. In this autonomic nervous system, we have cholinergic nerve fibers and the adrenergic nerve fibers. So why they are called cholinergic nerve fibers? Because they release acetylcholine. But why they are called adrenergic nerve fibers? Because they release noradrenaline and adrenaline, norepinephrine and epinephrine. Most of the parasympathetic nerve fibers are cholinergic nerve fibers. Okay. And most of the sympathetic nerve fibers are adrenergic nerve fibers, but there is some exceptions. We'll talk about it in the anatomy of autonomic nervous system. So if I tell you about the anatomy of autonomic nervous system, okay. In this diagram, you can appreciate there is the paravertebral chain from where the nerve fibers begin. So there is a ganglia. These are the ganglias. So before the ganglia, we have preganglionic nerve fibers, and after the ganglia, we have postganglionic nerve fibers. So you can see that every preganglionic nerve fibers release acetylcholine. Okay, so they are cholinergic nerve fibers. So every preganglionic nerve fibers are cholinergic nerve fibers. In autonomic nervous system, every preganglionic nerve fibers are cholinergic nerve fibers. But when we talk about the postganglionic nerve fibers, we can see that there are some fibers releasing acetylcholine and some fibers releasing norepinephrine and epinephrine. So there is adrenergic nerve fibers and cholinergic nerve fibers. Okay. So in the organs that are innervated by the parasympathetic nervous system is cardiac muscles, smooth muscles, glands, and nerve terminals. So we got cholinergic nerve fibers. In the sympathetic the organs related to the sympathetic nervous system, we got the norepinephrine. But we know that the sweat gland, this is an exception. Sweat gland is innervated, is controlled by the sympathetic nervous system, and it's a part of sympathetic nervous system. But we can see that the transmission, the nerve, the innervation is done by the cholinergic nerve fiber. So this is an exception. The exception is the sweat gland. Okay. So there is also something that's adrenal medulla. You can see there is adrenal medulla. So everywhere there is ganglia, but there is the adrenal medulla. Okay. So from adrenal medulla, we get epinephrine and norepinephrine. And obviously you can see that there is a somatic a nervous system. There is the skeletal muscle that is innervated by the somatic nervous system, but there is also the cholinergic nerve fibers innervating the skeletal muscle, obviously, skeletal muscle. Okay, now I'm going to talk about the cholinergic transmission. Okay, let's see. In cholinergic nerve transmission, we will see that there is a presynaptic nerve terminal. Okay, so there is a choline transporter. From that, choline enters into the presynaptic nerve terminal. Okay, so choline enters into the presynaptic nerve terminal. Choline enters into the presynaptic nerve terminal, and we have our mitochondria here. Okay, from mitochondria we get acetyl-CoA. So choline and acetyl-CoA together by acetyl-CoA transferase acetylcholine produced. Then the acetylcholine gets into the vesicle by a transporter called vesicle associated transporter. Okay, this vesicle has some proteins called synaptobrevin. Okay, and there are some proteins in the membranes also called SNAPs. Okay, so how this acetylcholine gets released into the synapse? For this, calcium should enter into the nerve terminal. When calcium enters into the nerve terminal, this calcium acts with the synaptobrevin, and it causes fusion of the synaptobrevin with the SNAPs, and the membrane get fused with the this vesicle get fused to the membrane, and acetylcholine is released. Okay, and now acetylcholine can act on the cholineceptors. This cholineceptor. This is a receptor. Okay. So there is some drugs and toxins that act on this transmission. Okay, like hemicolinium is a drug that blocks the choline transporter. Hemicolinium blocks the choline transporter. Okay, then there is vasamicol that blocks the vesicle associated transporter. There is called botulinum toxin. We have botulinum toxin that cleave these fusion proteins like synaptobrevin and SNAPs. By cleavage of these fusion proteins, it decreases the release of acetylcholine. And there is also the autoreceptor. Okay, when acetylcholine binds with this autoreceptor, by negative feedback mechanism, it decreases the release of acetylcholine into the synapse. Okay, so this is the cholinergic transmission. But here I want to talk about something called tetanus toxin. Let's talk about tetanus toxin. Okay, so I'm going to talk about the tetanus toxin because it's somewhat related to botulinum toxin. Botulinum toxin causes muscle paralysis. By cleavage of the fusion fibers, it decreases the release of acetylcholine into the neuromuscular junction. And by this mechanism, it causes muscle paralysis. But tetanus toxin doesn't do muscle paralysis. It causes muscle spasm, but it also do the cleavage of fusion proteins. So it do the cleavage of fusion proteins. But where? It did the cleavage of fusion proteins in inhibiting neurons of spinal cord. So the inhibiting neurons of the spinal cord gets inhibited. So when the inhibiting neurons of spinal cord gets inhibited, the excitatory neurons get the upper hand, and they causes excessive contraction of the muscles, skeletal muscles, and then it causes muscle spasm. Okay, now we talk about the adrenergic transmission. Let's talk about adrenergic transmission. Okay, let's talk about adrenergic transmission. So in adrenergic transmission, there is obviously presynaptic nerve terminal and postsynaptic membrane. Okay, so in presynaptic nerve terminal, there is a sodium dependent transporter, and by the sodium dependent transporter, tyrosine gets into the nerve terminal. Tyrosine, by tyrosine hydroxylase enzyme, converts into the dopa, and dopa, by dopa decarboxylase enzyme, converts into the dopamine. Okay, then dopamine gets entered into the vesicle by vesicle monoamine transporter, and this dopamine convert into the norepinephrine into the vesicle by enzyme called dopamine beta hydroxylase. So I can write it here, dopamine beta hydroxylase. Okay, there is also that synaptobravine molecule, and there is also the SNAPs proteins, and when the calcium gets entered into the nerve terminal, it causes fusion of the vesicle with the membrane and the norepinephrine release into the synapse. So what happens to norepinephrine when it's released into the synapse? So it can act on the receptor. Okay, it can be metabolized by the COMT enzyme. It can be metabolized by the COMT enzyme. COMT means catechol O methyl transferase. So catechol O methyl transferase really metabolize the catecholamines, okay, which have catechol rings. So we will talk about the catecholamines in other videos, obviously. And just know that catechol O methyl transferase metabolize the catecholamines. And there is also a norepinephrine transporter. Okay, this is also called the reuptake 1. This is also called reuptake 1. So by this norepinephrine transporter or reuptake 1, norepinephrine gets into the vesicle, into the presynaptic nerve terminal again, and here it can be metabolized by monoamine oxidase. Okay, monoamine oxidase. So there are also some drugs that interferes with this transmission. So there is the cocaine and tricyclic antidepressants that inhibit the norepinephrine transporter. By inhibiting the norepinephrine transporter, it increases the concentration of norepinephrine into the synapse, so that it can act more and more on the receptors. Okay. There is also the drugs called amphetamine, ephedrine, and tyramine. These drugs gets into the presynaptic nerve terminal and enter through the norepinephrine transporter. By entering through the norepinephrine transporter, it gets into the vesicle by vesicle monoamine transporter. It gets into the vesicle by vesicle monoamine transporter. Okay, and it releases the norepinephrine from the vesicle. So when the norepinephrine gets released from the vesicle, norepinephrine released into the synapse. Okay, and it acts more on the receptor, and so that these drugs are called indirectly acting sympathomimetic drugs. Okay, because they don't react with the receptors directly, but they increases the release of norepinephrine into the synapse. So they are called indirectly acting sympathomimetic drugs. Why it's called sympathomimetic drugs? Because it mimics like the sympathetic nervous system. How the sympathetic nervous system acts, it produces the sympathetic actions. Okay, so these are called sympathomimetic drugs, indirectly acting sympathomimetic drugs. So that's all for this video, and I will talk more about it in the next videos.